Hello viewers. In my earlier video I show you how magnetic contacts work, the technology behind the working mechanism of these magnetic contacts. In this video today I will easily show how to connect this magnetic contact. In many videos you see that this kind of NO and NC switches are used to show how to connect the magnetic contacts. Instead of using this kind of switch, I will show you the normal switch, the easy way you can connect these magnetic contacts. This is a calling bell switch. I will be using this. This is a and this is a normal light switch. We'll be using these two switch together. This is a normal switch, so we'll use these two switch and connect the magnetic contact, and we'll use this, we'll consider this as a load. So now let's get started. I'll be using two circuit breakers, one for the load and one to run the magnetic contactor. So this is to show you, if you have a motor or any load in your garage or your barn or somewhere distance, that load is connected to the mains of that location, and you can control it from your house or anywhere else with a separate circuit breaker. So let's do it. Before we fix the magnetic contact here, just showing you the connections for the power coil is here. These two connections are for the power coil, and these are the connections. Okay, now let's fix the magnetic contact here. Okay, we'll fix it. Yes, now we connect the load supply from here to these two connections, and we'll connect the power supply from this circuit breaker through these switches to this coil. I've connected the magnetic contact with the circuit breaker and the load here with this magnetic contact. Now if I turn the circuit breaker on and I push this down, you'll see the load is running. It is showing 235 volt, but it should be actually 220 volt. There is a higher voltage on the line. Now what I'll need to do, I need to connect the magnetic contact with this switch through this circuit breaker. So when I turn on this switch, this magnetic contact will automatically turn on the load. First we'll connect the negative wire. We'll connect the negative wire directly with the circuit breaker. Okay, so we have connected the negative wire with the circuit breaker. For positive wiring, we'll connect this positive wire with the circuit breaker and the switch. Now this is the switch line in. So we'll connect this wire. Okay, and we'll connect another wire for line out. Okay, now we'll put both the wire through here. And we'll connect the positive wire to the circuit breaker. Okay, so we have connected this switch with the positive wire and the circuit breaker. Now it's time to connect this positive wire with the magnetic contact coil. Okay, now it's connected. Now here is the load, and we have connected power from the circuit breaker through this switch to this magnetic contact. Now that switch is connected, if we turn on the switch, this magnetic contact will turn on the load. First, I'm switching on the circuit breaker of the load. Now I am switching on the circuit breaker that will run the contactor. Now if I press this switch, this load should get started. This magnetic contact will be on and this load will be on. Let's see. You see, it's running. So what happens if in case of any power failure, what will happen? In case of power failure, I'm switching the circuit breaker off. So the magnetic contact becomes off and the load becomes off. When power will come, it will then get started automatically because this switch is turned on. So if I am running a water pump or any load which I need to shut off within half an hour or 1 hour, in case of power failure, if I forget to turn the switch off, when the power comes, it will be started. So that is a problem. So the phase that is coming directly from the switch to this magnetic contact, we'll disconnect it and we'll connect this in this point of the magnetic contactor. So what happens? The phase will come to this point of this magnetic contact, and when the magnetic contact is on, then it will get connect to this point. So we will add a wire from this point to the magnetic contactor's coil. So we'll connect this wire from this magnetic contactor point, okay, to the magnetic contact coil. Okay. Now what happens? When I turn on this switch, the phase will have current at this point, but it will not pass through here. Now let's check it. So I am turning this switch on, nothing happens, it's not working. But if this magnetic contactor were on, if I push this down, see what happens? It gets electricity from this point to this point, and it is going to the coil, and the magnetic contact is on and the load is on. So what happens? If I turn this switch off, it will shut down. Now I'm doing it by pushing this down manually. So what we need to do, we'll take a phase through this switch and get a connection to this coil at this point or at this point, any point, to get this magnetic contact running. I'm opening this switch. And I will connect this wire through this switch to this point of this magnetic contact. The phase coming through here, and when the switch is on, it's going through here to the magnetic contact over here. Now I have connected this wire to this push button switch, and when I push this switch, it will come through this wire, and I will connect this wire to this point of the magnetic contactor. If I turn this switch on, nothing happens. If I check here, you see there is power, but power is not getting through the magnetic contact to this point. Unless the power doesn't get to this point, it will not get connected to the coil and turn this magnetic contact on. So I'll just push this conning bell switch once, and it's started. The load is running. So what happens? When I pushed it, the power came directly to this point, and it started the magnetic contact, and eventually the phase that is coming through here got connected through this magnetic contact connection point and going to the coil. So if I want to turn this off, I'll just switch off the power switch and it's off. So if I want to turn it on, I'll switch on the power supply, then I'll push the conning bell switch and it's on. The benefit of this connection is that if there is a power failure, the power is off, what happens? It's stopped. This switch is on. When power comes in, you'll see nothing happens. This load is not running. So we don't want this load running when the power comes. So this is the benefit of this connection. In my next video, I'll show you how to connect automatic timer with this magnetic contact. So when I turn this switch on, this magnetic contact will get started, and after certain time it will switch off the magnetic contact, and eventually it will switch off the load. So if you have learned anything from this video or you like this video, please give it a thumbs up and subscribe to my channel and push the bell icon. Thank you very much.